Hello. For those joining us live, this will feel like a whole separate day because, we got started on the first part of this lecture previously. But for those joining us, most of you watching the pre-records, this is probably just moments after the last lecture. So we're going to get straight into it, therefore, and keep going through our 4.2 HTTP server lecture. The really quick recap, just in case you did watch it previously, was that at the end of the last lecture, we created a NodeJS Express server, which did really basic things. It just had a URL, and if you accessed that URL while the server was running, you got some information that was sent from that server. In this particular case, the sending of some kind of text-based message. What we looked at in the previous slides was all about essentially preparing you to understand a really common way that web servers are used. And there's really, this is a very generalized statement, but there's two major ways that you'll see web servers used. One is to serve static content, and what that means is to essentially, here's a URL, get me the data at that URL. That happens all the time on the internet. Again, that happens on things like Wikipedia. It happens on things like WebCMS3, where you're essentially taking in a URL to load a page of content, and the page of content you load is written in some kind of web language. But a far more generalized and maybe topical thing that you'll use web servers for is for the use in an API. And I'm sure API is something you've heard about plenty in your time, no doubt. You probably heard about it here and there and everywhere else. So we're just going to kind of talk briefly about what exactly this is and what relevance it has to the project, and hopefully teach you a little bit about software, particularly server-based software in general. So firstly, an API, where the A, P and the I stand for Application Programming Interface, which is a bit of like a non-phrase, right? Like Application Programming Interface. It makes sense when you think about it, but it's very, very literal and conceptual. It refers to an interface exposed by a particular piece of software. So what that means is that, and when we say interface exposed, what we're really talking about there is essentially, for what most people in your position would understand, I'm just logging into GitLab, it's basically a set of functions, And the reason I point to this is because before we get to, again, abstract about it, I just want to point you to an interface that you have probably been interacting with a lot in the last few days, depending on when you're watching this, which is the project backend. And in this particular iteration 1 that you're doing now, we have this interface table. And all an interface really is, as per the slides, right, is it's a contract between particular services. So what the interface actually is, when you really bubble it down, is it's saying, I am a piece of software, the 1531 major project, and I have functions, and those functions do things. And then on that line there, where we say I have functions that do things, people on one side of the line will use your functions and consume them and work with them. And on the other side of the line, people, like what you're doing right now with iteration 1, will implement them. They will build them. And an API is simply referring to an interface that a piece of software exposes. So you could argue, if you really wanted, that this interface here is an API. It would be a very strange API, well, not strange API, but it would be a very poorly documented API, but it would still be an API nonetheless, because it is simply an abstraction of software that hides away the implementation, that allows someone to use it and know how to use it. And yeah, that's kind of a lot of what there is to it. If you're not really sure what we mean by using your API, it's actually kind of, in the context of iteration 1, it's actually your tests that are using your API. Like, again, think about it. You have this interface table, which has the interface in it, the API, if you will, and then you go and implement it, this kind of back-end stuff, and then someone uses your code and actually tries to make a program happen with it, which are your tests, essentially. But in the future, that might be an actual web page or a website somewhere. So that's what an API is. Now, the most common usage we see of APIs are web APIs, and that's simply because APIs mostly exist where person A creates some software, they create a nice, easy to understand interface, they go and build out all the complex backend, and then person B, C, D, E over here kind of use that API. That's the most common case. And the easiest way for people to use things all around the world is through the internet, and the easiest way to use things over the internet is to kind of leverage the web, as we talked about in the last lecture. So if it wasn't already applied, the interface basically acts like a black box and indicates that for a particular endpoint, input, output, and just generally behavior. So again, back to this interface here, this function auth login v1, it tells you what it does. It tells you the parameters, the return types, and error cases, but it doesn't actually show you the implementation because you treat it like a black box. So that's what an API is. Now, in the world of web APIs, which is where things get a little bit more interesting, web APIs are just APIs that are built and sent over the HTTP protocol, as in the web protocol, the one we looked at. And it's all based on URLs, right? Because the HTTP protocol is just a bunch of URLs being sent back and forth. What's important to understand about how the web works, typically in a modern application, and this is again just a very quick summary, is that what a web browser like this one I'm using here with Microsoft Edge will do is it will go and it will itself make a request to a server and say, hey, can I load the web page? And you get the web page back. That happens all the time. Again, on Web CMS 3, it's a really simple example. I load the page, I get the page back, the page loads on the screen. However, after that initial page load, a really common thing that most applications do these days is they keep talking to a server through some kind of API as they go. And some examples of this might be, and I'll just show you, for instance, if I open up YouTube for a second, right, and I'm not signed into YouTube here, and again, this is not in the course specifically, because everything to do with web browsers is not really critical in the course, but if I open up this here, this is like a bit of a debugging tool we have in a web browser. And the one thing I just want to point you to here is that, and let me just find the exact, there's going to be a lot of information there. Basically, to load this web page, all of this stuff you see here, these are different files, different images, the Mr. Beast images, the Mr. Bean images. These are all different files that servers are bringing to a web browser. But that doesn't have a lot to do with APIs necessarily. But where APIs get more interesting is that on this page, if I click on a particular button here, the web browser will have to talk to the server to get more information back. So you see if I click on music here, it will go and actually make some more requests and do some more things. So what you'd actually say here is YouTube is talking to the YouTube API, and they are kind of constantly getting that information. And this doesn't have to mean, like, if YouTube wants to use an API, it doesn't mean that YouTube has to use it. You know, a really common example of one company using another company's API would be Airbnb, right? So this is an Airbnb website, and what would actually be happening here is that when you scroll down on an Airbnb website and you see this kind of map here, this Airbnb is actually talking to a Google API, where Google has essentially a Google Maps piece of software like your major project. And I can look this up, Google Maps API, and you'll typically see that this is a very complex API, so it's probably going to be directions API. So imagine you're a software developer and you're like, I really want to create a Google Maps, but I'm making Uber and I want to be able to like tell my drivers where to go. So there's actually a Google Maps directions API, and I do worry that this might be such a big complex library that it might be hard to look at. Again, I shouldn't pick random examples on the fly. Directions API overview. Am I going to get sent in circles here? Maybe. I'll give you a really simple API that we were working with recently at work. It's just like quite a straightforward one. There's this great product out there called Kenny. It's a really small US company. And what happens with Kenny is that they are essentially a customer feedback management tool. So they build websites where if you have a little like product that you build, maybe you make a little project, you can actually use them as another product to let people be like, I want this feature, I want that feature, kind of like feature voting, so that you can have a community of people who help essentially vote on what they want. And what's interesting about Kenny is that it has an API, and you'll actually find a lot of popular services you like have an API. And if I go to the API, you will actually see that Kenny, think of it as like a forum. It has a bunch of things like saying, hey, you can make a post and you can comment on that post. And if you want to create a comment on a post, it kind of tells you, okay, here is a function, essentially a URL. If you think about HTTP URLs as basically functions, it makes life a bit easier. And then it says, here are your arguments, here are your parameters and the types they are, and then it says, this is what gets returned here. So this is a very universal, common concept. You know, it's not just something we throw at you in the 1531 project. This idea of function, or, you know, in the case of web servers, URLs, parameters, return types, all of that's pretty standard. And you'll find this for most things. Like Google Sheets have their own API. I mean, Google Docs, like you'll find a ton of software. Google Docs API. I've never even looked at this. Usually you look for like developer guides or reference docs or something. Not that you need to, but, and to be honest, a lot of Google stuff is very like intense and complicated, for instance. But point is that there'd be documentation somewhere here. Yeah, it's all a bit of a lot. It's a lot to take in. These kinds of simple docs like the one I showed you with Kenny are much simpler. But the point is that that's what an API is. These are web APIs. They are literally everywhere over the internet. There's one for Discord. I'm sure that a bunch of you know, people in CSE who love Discord might have made their own API or worked with their own API here. Again, I haven't clicked on this before. The one I prepared was the Kenny one, but you can kind of see here that, oh god, again, not making stuff up, but it's all of a kind of very similar thread at the end. Yeah, so here you go. Here it's a similar thing. Here's a website URL. Here are some fields that you can take in. It tells you maybe what it returns. It's just a lot of documentation. So if we go back to the slides, the way most websites work these days is that they load the page, and then that page is constantly talking to the server through some kind of API to get and collect data. And that's how a lot of modern websites will do things for you. Like again on YouTube, if you like a video, it just kind of is liked suddenly. But what's actually happening is in the background, the YouTube web page is actually talking to the YouTube server via an API. It's probably an internal API, you know, inside the company, and they're doing stuff. One really common way that we communicate through this web-based API is through what we call building some kind of Restful API. And Restful is essentially an API that uses the 4 HTTP requests, which are get, post, put, and delete. And these, oh, sorry, there's like a band-aid I have that I'm like half ripping off. It hurts. And these describe all the main actions you can do on a web browser, so on a web server. So let's go back to the code we had from last lecture, because I think if you see some code, this will start to make more sense. And this is the code we had here. We had our 4.2 Express Basic. And what you notice is that we actually had one of these 4 types already, which was a GET request. So this app here is our web server, but when we say .get, what we're actually doing is we are telling the web server that we would like to make one particular type of a HTTP request. Because remember, HTTP is the protocol that's used to communicate over the web, right? But there are 4 kind of methods that are used. There's get, post, put, and delete. And the 4 of those together essentially mean, get means to read. Makes sense, right? Like get's like read only, post is to create, put is to update, and delete is to delete. And these 4 operations we sometimes refer to as Crud Operations, which is CRUD. That's the operation column here. So sometimes you'll say, you know, I've got a RESTful API just doing some basic CRUD things, which really does just mean that you're using post, get, put, and delete like this. Now we'll talk more about what those mean in a second when we look at this particular server here. But to start you off and to go into a little bit of depth, what is quite common is simply that you will have a server and you will have a bunch of, say, these GET requests. You might have some POST requests. You might have some delete requests and a few other things. But you've got these get, post, put, and delete. Now, the first thing you might be thinking is like, whoa, we got, what are these 4 things and like how are they different? The CRUD operations themselves are actually they don't really mean anything inherently in terms of, they're kind of like, in C how sometimes you'll create a constant variable with an uppercase, and sometimes like a constant variable, and it might be able to be like something that you intend not to be modified might actually be able to be modified, but we use conventions to articulate and communicate things. So it's not like a get request here, get HTTP method is exactly read-only in terms of, nothing can happen to modify anything, because anything can happen. You as a programmer could completely have a get request go and delete the whole website or something. It's more, again, just convention. But let's look at some code, because I know this is going to get a little bit too heady for some people. So where is it? What is it? 4.2 CRUD. So what we've got here is we've got a very basic server that does a few very interesting things. And it's actually an expansion on the last server, but let me point out some of the key differences. So firstly, I've got 2 HTTP routes, we would call them, which is /apple and that's /orange. That means that if I go to HTTP /localhost, like if I go to HTTP /localhost, port 3001, because that's the port we're running, /apple, if I type in that URL into the web browser and my server is running, it will come and find this particular function. This particular function, because it's what's written here, and then the code inside of it will actually be called and run. And what you'll notice here is that my get request apple, if we start this up, so let's start it up, and go inside of M2, npm run ts node source /4.2 CRUD, like this, and we get the server running. Let's see what happens when we actually go to this URL. So if I open up Firefox or something, doesn't really matter, and I go to localhost 3001/apple, what you'll see is that I got this kind of interesting response which said, let me move my head there. Yeah, it says, brace message, hi undefined, thanks for sending apple. And I go back to my code and I take a look. And I say that, okay, well, const name equals request.query.name, whatever the hell that is. And then you'll see that I'm sending something back. But if you remember in the first example, I sent back a string, basically a piece of text. Whereas what I'm sending back here is some JSON. So what I'm doing is I'm grabbing this object, which is one object with a key in it, and that key is message, and that message is a string that says, hi name, thanks for sending apple. And I'm taking that object and I'm JSON stringifying it into a string, because the internet doesn't understand JavaScript objects, but it does understand what ASCII is. And by stringifying it with JSON, I can convert whatever I'm doing into ASCII, which is really, really useful. So this kind of makes sense. It's very similar to the last example. I'm not returning raw text. I'm returning the JSON stringed version of some other text. And then here you'll see that the name, I could rename this to Hayden or something and restart my server, and it would, kind of behave how you'd expect in terms of it would now print out something to do with Hayden as opposed to undefined, right? But we don't want it to be Hayden. So what is this request.query.name? Well, the way that the web works is that certain types of requests, like GET requests, if you want the route to take in information, right? Because maybe I want, when I call /apple, I want it to give me this cute message back. Sorry, let me just get to the page. Oh, that's my personal computer. Sorry. Yeah, so like what I want it to do is to print out this nice message based on an input. But how do I input it? It's not a function. I can't just like add a parameter here. I could try, but that won't work. And the way we do it with a web-based interaction is for get variables, we can actually pass it through the URL. And you've probably seen this around all the time. If I say localhost 3001 /apple (name equals Hayden), this information here after the question mark is basically the function parameters. And when I run that, you'll see that I get the same thing now, but I have to restart my server because I kind of hacked it to get it working. You'll see that when I refresh this, it now works, but if I change this to Sally, it now says Sally. And what's really interesting about this is you can actually start to see how this is forming already, whereby instead of having functions with parameters and return types, I actually have here a URL, which is basically a function name. And that URL is taking in parameters through the URL as well, and then it's returning to the web page some kind of return result, which in this case is just a string. And in most cases, it's some kind of string. And yeah, that's a big part of it. And this is actually the foundations of an API. And you'll find that most web APIs are actually structured very similarly to this in many ways, in the sense that it's quite literally a collection of URLs, takes in parameters, and you get some kind of string response back. Now, it is very common for those, I'm sorry I'm fidgeting tonight, for those string responses to be JSON based. So they're based, JSON text based. Because that's just, again, if you think back to lecture 3.1, that is I think it's 3.1, the one about data interchange formats and standard interfaces. It's just an easy way where it doesn't matter if the server's built in C or JavaScript or Python or Java, you can always send back information, and it's a language that everyone understands. So if you have a program on the front end not running with JavaScript, then you are able to still digest that information. So that's kind of a bit more of an elaboration of what this stuff is with APIs and whatnot. And you could kind of start to imagine you could have a very expansive API. For instance, like imagine I create another one called app.get, and then I say /time, and then I go request response, and then inside of here all I'm going to do is I'm going to just send back a stringified JSON of an object. And that object's just going to say time, and then all I'm going to do here is say, I'm just going to return new date dot to local string, which is like a friendly string format, And I'm now just going to restart my server, and I've created another route, or essentially another interface, another function on the web interface, where if instead of going to Apple, I go to time, it will actually give me the time, and when I refresh it, I get the new time. And this is really handy because now, again, you can kind of imagine this is kind of us building on an API, where this API now has a time router, a time function. No parameters. It's a parameterless, argumentless function, but it returns something, and that something is a string as well. And we can just keep expanding and expanding that concept. Now, where things get interesting on the RESTful API is that not everything's just a get method. We also have these other methods that are post, put, and delete methods. And again, get means read. So, these two routes we had here, get Apple and get time, these are all us reading some information. We're not creating information or updating information or deleting information. We are simply reading it. Now, what's really interesting is, I'm just going to see if we should jump ahead a few slides and then come back, which I think we should. I think I might have, yeah. So let's jump ahead a few slides and then come back. With this, most web browsers, though, inherently, in terms of what a user like you and me can use just by typing in a URL, always send requests via GET. It's just how they're built. So when you type a website or a URL into the address bar there and you hit enter, it's going to make a GET request to that particular URL for you to the server. And I can see that pretty easily just by opening up the network tab again and refreshing. And if I look on the very first request here, you can see it's a GET request. You're not required to have a look at any of the information I've got up kind of here, just generally below me. That's totally unrelated. But yeah, as you can see, it's relatively, it's always a GET request. So what we really need to have more interesting conversations with a web server than just what a web browser can do, which is quite limited, is to actually talk to it some way. Now, there are three main ways that we discuss in this course to talk to a web server. The first one is via the second one is via a web browser, which we've kind of demonstrated so far. But the first one is through what we call an API client, which is essentially a tool designed for talking to APIs. And then the third one is an NPM library that is essentially a coding library that helps you make them, which will be really, really useful for iteration 2. So on the API client front, an API client is, again, just a program that is used to talk to APIs. There are a whole bunch of these programs. Two common ones, like I use one at work called Insomnia, which is really good. Postman's a common one. One of them ones that we usually recommend in 1.5.3.1 just because it's lightweight is ARC, which is the Advanced REST Client. And you can install these on pretty much most Chrome or Firefox-based browsers by just go ARC add-on in Chrome, and well, this one's a Chrome add-on, so I should probably open it up in Chrome. Switch to Chrome. Yes. I don't want to download Chrome. Chromium. Quit. And what I can do here is if I go ARC add-on into Chrome, I can actually, again, find it on the Chrome store, so maybe not Firefox, I'm not sure. I can go launch app. I've actually already installed it, but you can go and open this up yourself anytime. And this actually runs like a browser app, so you don't need to install it to your system. It kind of runs through the Chrome engine, if you will. Though it's being a little bit grumpy today. I think sometimes it might take a second. I'm not too sure why, but there are other ones you can see. For instance, again, there's a Postman API, which I'm not even sure. Sometimes they deprecate things. Yeah, see, for instance, in this case here, Postman was a useful one, but they kind of decided to stop serving it through the Chrome add-on library and instead serve it as a dedicated app, just like you download one on your computer. So I'm just going to try and Chrome add-on again. I'm just going to try and get back to this and see why it's not working. Maybe we can uninstall it and reinstall it. Extensions. Yes, how do I'm not sure why it's not doing it. How do I see my add-ons? Settings, my extensions and apps. Oh, no. Why? Just launch. Let me try closing it and reopening it. Cool, and then I go ARC add-on. Try it again. Launch app. The ARC extension's also deprecated now, is it? Oh no. The problem is you can't really install things natively on the CSE machine. Sometimes if they have... Yeah, sometimes they'll have standalone things to run. Oh, that's not good. Mate J says, can these web APIs be accessed by mobile apps, not just web browsers? Yeah, it can be accessed by anyone with the internet. That's why it's so exciting, because if a technology is capable of sending an HTTP request, then anyone can open it. I would like to sort this out. This is annoying. How do I uninstall it? Well, let's just try and find a random one on the internet. API client. See what we find. Boomerang. Okay. This. Well, let's try this out. This is probably a terrible idea, but let's give it a go. I've never seen or heard of this before. I'm sure it's fine. They're all kind of the same. It installed on Chrome. I can see there's an extension there. Will you let me manage extensions with it? Oh, good. Thank you. Sorry, now I can remove it. Let me try and reinstall it. I'm not sure if... Sorry. Normally this just works, but if I add it now, maybe it'll be happy because I reset it. Let's try it out. Okay, there we go. All right. Well, we're sticking with this one. Sorry, Boomerang. I don't love you very much. So this is a API client, and you'll see here I've still got my server running, and they're kind of like web browsers in the sense that you type in a URL and some parameters and stuff, and I'll show you here. I can also type in localhost 3001 /Apple, and you know, question mark name equals Hayden like this, and when I click send, sorry, it's trying to send it securely. You can ignore that for a second. I get this result here. You know, message say, you know, hi Hayden, thanks for sending Apple. And if I say, you know, Sally again, it says hi Sally. So this is like a little tool where I can easily do this. You might be thinking, why is this so different from the web browser? What's so exciting about it? And the answer is that I can actually change the methods that I send on. I know there's a lot here, but don't worry about those. And I can send it via, you know, if you go back to the CRUD ones, I can send it through like a post to put or delete. And if you look at my code here, if you come back to my code, you'll see that in my server, I also have a post method called orange. And what orange does here is similar, but also slightly different, which is that it still returns hi so-and-so, thanks for sending orange. But the way that I've consumed the information here is a little bit different. This is where things get weird. You notice that with the get one, I consume the information via the URL. Right? I pulled, like, request is the incoming message, query is the URL parameters, and then name here is a property of that. And just to be clear too, I can send multiple things. If I say like name and age, let's say request.query.age, and then I modify my string, you know, hi name of age, and I restart my server, you can send as much information, well, not as much, but you can send a lot of information through the URL simply by adding more information after it. And the way URLs work is that the first, and let me copy this into something a little bigger so you can see it, all of the data coming in from the query is separated by a question mark. So it's like the URL here, question mark, and then the data. And this URL is made up of the protocol, which we know is HTTP. It's made up of the domain, or what you might normally call the website, and then the port, which on most production servers is the same, so you actually normally don't need that when you're using the internet. And then we call this here the path, which is kind of analogous to what you understand, you know, that a function name is. And then the data's here, and the data's just basically key equals value, and for each piece of data we use an ampersand to separate it. So if I was to add more, I can add more like this, basically. So we got that information there, but again, when it comes to these post requests, like you see here, we're not capturing that information via the query, and that's because with post requests, we send the information through what we call the body, which might be a bit of a new concept. So if I go and make a post request to orange, I don't need any more query parameters, but if I want to send information, for instance, the name, I actually have to go to the body part here, and I have to send it some JSON. So in the JSON is going to say, you know, name is Hayden. So instead of putting it in the query, I'm now putting it in the body. Now, the body, you got to think of it like, this is the equivalent of, you know, think about HTTP as, you know, mail. I write you a letter. That, you know, hi so-and-so, hi Gab, really nice to see you in the 1531 lectures. You know, it was a great time. I wrap that up in a letter. I put my address, I put the address of where I want it to go to, and then I put the return address so I know where it comes back or something like this. The analogy doesn't carry perfectly, but using query, putting data in the query like we did for GET requests on the server is like adding more information to the address. It's publicly visible, it's right there, it's really simple. You don't have to kind of open up the envelope and shove more data in. But adding it into the body is the equivalent of putting it inside the letter that's in the envelope. And over the internet, when we send information, typically you can look at the letter. Like anyone working at the post office can see where you're sending your mail to, but they don't know what's inside of it. So I'm simplifying a few things here, but that's kind of what we're doing when we send it through the body here. And when I click send, we'll get an error because I probably got an error in my code. What do I got here? Oh, okay, so and this is probably a useful tool with debugging. You probably noticed that when I called this URL here, the Sally one, I got this little green thing, and the green thing said 200 OK. There's a few really important errors that you'll see when it comes to web development. The first one is 200, which means happy face. You got 400, which means basically invalid parameter passed in. You've got 403, which means you aren't authorized to access this. You got 404, which means this route does not exist, and then you've got 500, which means that the server something bad went wrong on the server. And that's why you'll see here, when I look at my results, this one was 200 okay, but when I called the orange route, I got this. Oh, it worked that time? Alright, well, you saw before there was a 500 here, and that 500 basically says that the server had an error. And in fact, if I go back to the error, you can see here that the server had an error on the terminal. Now, you'll notice that these are pretty logically split up, where 200 stuff is okay. 500 stuff means that the server made a mistake, the thing you wrote in this course, and 400 means the person who's giving information to the server did something wrong. So, for instance, if I try to access a HTTP route, like orange with 2 E's, and I send it, I get a 404. Which means that me, the person trying to talk to your server, made a mistake. Whereas if I do this right here, then it says 200 acceptable. And similarly, I could change what's in the body from Hayden to Sally, and we would see that we would get the new request come through, and it would say, "Hi Sally, thanks for sending orange." So that's a post request. Now, if you're paying attention, you might remember that before we said that GET requests are about reading, post requests are about creating, put requests are about updating, delete requests are about deleting. You might think, okay, Hayden, but you didn't create anything. You made a post request here, but you didn't actually create anything. You just printed out the name. And you're right, because if we scroll further down, post requests aren't actually forcing you to do anything. They are communication tools. So my post request is kind of what should probably be a GET request. I should probably rename this to a GET request because I'm not creating or updating or deleting anything. I'm just adding something, reading something. So that's just really important. Those 4 keywords are instructive. They're not constraints. They're not technical words in many ways. There's a few things with them, but you getting them right is just based off, not that you ever have to really get them right in the course because we tell you what they are, but yeah, they don't mean any, like they don't mean something really deeply to the server. Like the server's not going to be like, hey, you said this was read only, but you modified something. Now, just to help kind of carry this example a bit, we're going to keep moving on and then loop back to it. This was the piece of code we just kind of looked through. And we talked a bit about using the query, and then we talked a bit about using the body, and basically the way that HTTP and CRUD and stuff is set up, and this is actually kind of somewhat baked in stone, is that GET and delete requests don't take in a body, and you tend to send information to them like function parameters or arguments through the URL. So if you have a GET request or some kind of delete request, when you call it, that information will come through in the URL. But when you have a put request or a post request, and we saw a post request, you send that information through to the body, via the body, like you saw there on ARC. Now, all 4 of those, get, delete, put, and post, they will all send the data back via JSON. Now, that's not, again, a requirement of the server. That's just what you'd call common convention. You'd find most APIs out there, I'd say 99%, probably more, would return JSON definitely. And also what I kind of glossed over is that typically most servers will expect that you send the body information via JSON as well. And we kind of implicitly did that. If you have a look at my body here, this is valid JSON. Now in this case here, we sent it as text. We just sent it as a string across the internet. And as soon as our server caught it, it parsed that string with the JSON.parse. It took the body and it kind of unJSONed it into JavaScript object, and that's where we got the body here, and then we got the name out of that object. So body here is an object with 1 key. It's the unpacked from JSON version of this. Okay. Now, I mentioned before that 99% probably of APIs are done with JSON, always returning JSON, and for post and put functions, operations, they take JSON in through the body. So what was actually done because someone realized everyone was doing this, was some modifications were added to Express, where if your server is going to be pretty much exclusively dealing with JSON, instead of saying that your server is working with text, you can change this from text to JSON. And then similarly here, when you have your response.sends, instead of having to kind of say, I want you to send text, and that text is the JSONified JavaScript object, you can actually just say response.json like this, and essentially Express will do that same thing for you. It will actually say, oh, thank you for your JavaScript object. I will go and convert that to JSON for you, and I will send it back out. And then the third one is for the put and the post requests. Instead of having to do JSON.parse, if you have this little thing up here with JSON, what it will allow you to do is to essentially do what we do with the queries and simply say request.body.name. Because by changing this from text to JSON, you've essentially told Express that all the inputs you're getting are in the JSON format. So when you get the body, actually kind of parse that and, you know, unscrew that and turn it into a JavaScript object for me, which would be really nice, right? So you'll see here when I stop this and run it again, I will get the same results. It's just I've had to write less code, which is nice. So I run that again. That works fine. I run the GET request. That works fine. Yeah. You don't do anything with JSON when it comes to inputs for get and delete. They just passed in the URL like this. That's okay. There are other ways you could do it, but that's just how we teach you to do it in this course. And yeah, these were the kind of key lines of code that got changed here compared to the previous example. Now there is a little task that we want to do, and we might do this at the end just to play around a little bit, but I'm not going to do it explicitly now because let's get to the end and then see how we're feeling. So back to API clients. We learned how to use ARC to do a get and a post request. That was cool. Doing a delete request or a put request is honestly identical. Like, I could take you through an example, but the actual code written would be nearly identical. So we've looked at ARC, we've made a couple of requests. We're familiar with web browsers because we were using them in this part, in the first part of this lecture. But let's get on to the far more exciting one, and the one you'll probably be working with a lot, which is an actual NPM library that allows you to make HTTP requests via code. So what I've got here is I've got some code, and in fact it's already sitting in a file ready for us to go here, and I'm using a particular library in NPM called sync request. It's essentially an HTTP library that I have to open another terminal. It's a library that allows us to do what ARC or those other API clients do, except to do it on terminal, or like in code more specifically. And all I have to do to use it, I don't know if I mentioned this here, yeah I did, is just run npm install sync requests. Now you could maybe say that maybe this should be a dev dependency or not. It really depends on how you're using it. So, you know, in this course it's probably a dev dependency because you're mainly going to be using it for tests, but again it depends what you're using. And I've just gone to install that, and then what I can do is I have this file here, I can just run it, and all that file does is it imports a request object from sync request, and then it makes a request. And you can see here that the request is a get request to this URL, localhost 3001 Apple name equals Hayden. And then what I do at the end is that it's a little bit long-winded, but I get the response, right? So this is the request made, so like sent to the server. And then when I get the response, I get the body from the response, which you've seen as this thing down the bottom here. I then convert it to a string, which you kind of have to do from what I can tell. And then you parse it as JSON, which isn't automatic for you. And then you console log that. So now with the server running, because remember our server's still running, I can actually just over in another terminal over here, I can just say npm run tsnode source/4.2 request.ts, and it will go and talk to the server. So, oh, hi Hayden of age undefined. Ooh, that's interesting. Why is that? Huh, I'm not sure. That doesn't make much sense. Oh, age undefined. Sorry, of course, because we added that extra thing. So yeah, similarly, if I wanted to add that other information, I could just add this here, age equals 18, like that. And then we just have to restart our server. And then we just run our test again. And all that's happening here is your server, the implementation is running over here, running. And your other code is just talking to that server. That's all that's really happening here. So this library is really, really simple to use. That's how you do it with get requests and delete requests, because all you have to say is get or delete, and then you just pass the information through the URL. That's all I have there, apparently. But two other things, and these are both important, is that what happens if I want to simplify my code? Well, you can actually take it further. Let me just check. Yep. And instead of manually encoding that here, I could actually clean up my code a bit and say, you know what, all of the parameters, all of the arguments I'm passing in, or my query string as it's called, is just name Hayden and age 18, like this. So instead of having to kind of manually write that in, which is a bit complicated, particularly if you have something dynamic, I can actually remove that bit and instead pass a query string in that is just my query string. Or if I say rename this to query string, just so it's a bit easier to understand. The request library takes in this kind of extra property QS, which is this query string variable, and it should do the exact same thing for us, which kind of makes our code a little bit cleaner and more dynamic without having to kind of manually type out the information straight into the URL. Now the next logical question is, what happens with my post requests? Okay, well let's say that this is our get request. What do our post requests do? Well, we know that with our post request that we are calling /orange, and we also know that it's not a get request, right? It's a post request. And then the body that we pass in that post request is actually going to be pretty much what you'd expect from some of the other examples, which is that we want to send some text, which normally you might be able to be like, all right, let's say that that text is just name is Hayden. So this should mostly work because that's like the body we're sending. Let's see if that works. Let's see what happens here. So I run this one. Okay, and it says hi undefined. Thanks for sending orange. Now, one of the annoying realities of working with this library is that there's actually a really critical line that you need to include, or a few lines, and it's in all the sample code we give you, but I'm just going to include it here, and that is that as well as your body, you also need to include this thing called headers and this other stuff. Don't worry about too much about what this is, but this is essentially information that comes with your request that tells the server, hey, I'm sending JSON, so it knows to like accept JSON, which is a little bit strange, and I'm pretty sure this should work. All this stuff is new code that I've written for this term. So you see now it will actually take it because it's like, oh, I understand what I'm getting now. I'm getting some information that's like, you know, got a body. So that works well, but obviously we don't want to have to write manual strings here, so we could do what we did before, which is, you know, you can just give it the stringified version of name as Hayden, like that. And now you can send that through, and then that will work as well. Oops. That will work fine, and you'll get, hi Hayden, thanks for sending oranges. So the request, like the sync request library, can do both get, delete, and put post totally fine. And I've just given you some very straightforward examples that demonstrate all of that. Right? That's totally normal. That's totally fine. What you're doing a lot in iteration 2 is just expanding on that. And in particular, you'll be using these libraries to write tests as well. Because what I've shown you so far is how to write a server that has, you know, Apple and Orange and stuff, and then also how to talk to that server. But the next step is to figure out how to write tests that talk to that server. So we'll do that after the break. We're going to take a 10-minute break now till 7:05, and then we'll keep going. Okay, so now we're going to try and actually tie all these pieces together to give you a better sense of how iteration 2, which is about, you know, HTTP and web stuff, how this all ties together, because you know that iteration 1 was about writing tests and implementing things. Iteration 2 is also about writing tests and implementing things, but those tests are HTTP based. So what I've got here is, I've got our server, we've got that running, as you'd expect. And then separately, we've got a nice file I made called 4.2 request.test.ts. And you'll see that it actually looks really similar to our request file, like this, except we've wrapped all of this inside of Jest. So now, Jest here is able to describe something, test something, and then actually run the test. And then what we do is we expect that the body, what's returned, we expect that the body's message, the message is the key, right, on the object here. That's what the message is. We expect that the body's message is equivalent to, "Hi Hayden, thanks for sending Apple." And then we do the exact same thing for test orange here. And what's great about that is rather than, running that, we can actually just do, npm run jest source/4.2 request.test.ts. Except, what have I done wrong here? Maybe I haven't installed something. Ooh, this is a horrible error. I don't know. I'm going to try and check something out. What's in the package.json? Let's make sure we got it right. What do we got? Jest calls jest. Okay. Cool. This wasn't happening when we prepared for it. So if you do run into some kind of random problem with this, it's very easy, like I'm doing right now, to assume that it's something out of your control. But typically, here's what you would do, right? You have something like this. I'm going to go copy the file contents here. Because I test all this code locally, but not all of it on VLab, right? So maybe there's something obscure happening. So what we do is let's reduce our test down to something really, really simple. So instead of doing all the request stuff, let's just test that true is true. And this way we can tell if it's something in our code or if it's something in how the library, in the way that it's all set up. So now we go to run, now we'll go and run our test again, like this. Okay, exact same thing. Well, this is kind of useful because now I know that it's not something to do with that. Done. Let me see if I can, let me just quickly see if this works for me locally. Maybe I can get around this for now and I can go and have a look at this later. So if I go inside here, what I'm going to do is I'm going to run the server here. We'll see if this works. So let me try and run npm run ts node source/4.2 crud. That's the server. Sorry, I think I forgot to npm install. This kind of happens, like sometimes at work we will have engineers spend an entire day on an error like this because modern computing is just stacks on stacks on stacks of this stuff, which just gets absolutely crazy. So let's navigate to this folder too, and now that my server's running, and just to show you, this is the server running locally here, and I can open it up locally, localhost 3001/Apple name equals Hayden in my URL like that. Hi Hayden, thanks for sending Apple. So it's all working. Now, and this will also help me discern whether it's the CSE machines or not. So if I run npm run jest source/4.2 request.test.ts, see what happens. Okay, so Jest actually ran here, but there's a separate error. Now, this is good because what it means is that there's some weird thing about the code I have that doesn't work on CSE, and I'll figure that out. By the time you're watching this, if you're watching the recording, it's probably already fixed. So go look at the code. But it's something to do with the CSE machine or just my account as well. Doesn't matter. Don't worry about it. I'll fix it. So let's just look at this particular example locally, which is where I wrote some of this stuff and tested it. You can see here that there are two tests, test apple and test orange. And you can see that test orange failed. And you can see that test orange failed because the server returned a status code 500. That means that the server had a problem, not us, right? Unexpected token O in JSON in string 1. Now, in position 1. Now, if you get a lot of these weird errors, the way that Express is designed is that if Express crashes, what it actually does is it doesn't just return an error, it actually returns an entire web page that is meant to be viewed by someone. It's just like the default behavior. So you can actually ignore all the fluffy stuff and just focus on the error here. And it's basically saying unexpected token in JSON at position 1 in JSON.parse. So let's go and have a look at our server. So I'm going to open up 4.2 crud.ts. Now we know it failed on orange. So let's come down to the post orange and you'll see it failed on JSON.parse here. So how do we debug this? Well, it's saying that JSON.parse failed. So what I'm going to do is I'm going to console.log request.body. And just for easiness, I'm going to also add a few equal signs in there just so I can see it a bit clearer. Okay, then I'm going to run my server again. I'm going to run the test again. And because I put the consoles on the server, when I run it, the data will come through on the server. So you'll see it pop up on the terminal behind. And you can see there that it is an empty object. So what that's saying is that the server is actually not getting any information being passed in, and therefore when you're saying parse it with JSON, JSON's like, parse what? It's an empty object and it's not enjoying itself very much. So let's go and have a look at our test file, right? Let's have a look at what we're sending. Now a lot of this stuff looks pretty reasonable. It looks like what we sent in our own VLab one, so maybe let's have a quick comparison. I look at our request here and what's like, let's try and compare the difference if we can. That's not the right file. There we go. So let's have a look at the difference. What do we think we've done wrong here? Request, post, localhost, orange, body, JSON, stringify, name, Hayden, headers, content type, application / JSON. That's kind of strange, right? Does anyone spot anything particularly odd about this or anything seemingly not written properly? It looks pretty okay. We got the headers like we talked about. We could always check whether this request file works too, right? We could always just go and, again, this is debugging. This is just like a natural part of things. I know we have this other file here, which is our 4.2 request.ts. And I'll replace this for a second with, that red is just tabs. I'll replace it with the one we know that worked, and let's try that one out. So instead of running our jest thing, let's just run our standard test. So now I'll just run npm run ts node 4.2 request.ts. Okay, I'm getting an error there. Because I forgot to include port request from sync request. Whoops, I removed too many lines in the code when we edited that. Okay, so now what do we have? We got another problem. We got the same thing. Oh no. Very complicated, some of this stuff, isn't it, right? We got a few weird things going on here. We're not sending, for some reason our package isn't being received by the server, which is kind of annoying. My memory, and let me just try this out, because I could have this wrong here, but sometimes what I've found, let's try it out where we don't actually JSONify it, because we're already telling it that we're sending it JSON. I don't think it'll like this. Again, these are all totally new libraries this term. Yep, it doesn't like that. So body always accepts a string here, that's what we could tell. JSON.stringify. Great. Cool. Is actually really, the reason we're not getting anything there is actually really simple. It's because, if you remember, in the earlier example we did, we went and changed the .text to .json. And why did we say we did that? Because we said that without changing the .text to .json, the Express server does not know how to take JSON and process it and populate it into request.body. So by making that one simple change, you will find that immediately the original request file works, or doesn't work. What's the problem now? You can see that we're getting the body now, right? We're actually getting that passed in. Let me open up this file just beside it for you so you can see it. You can see now we are getting the body passed in, but also therefore I don't need to pass the body in to parse it, right? Like think about what we did back on VLab before. We just simply said const name equals request.body.name. So we can do the exact same thing. Here we can say request name equals request.body.name, and then this should in theory work. Should be fine. Oh Lord, what's happening? Was it the same thing? I think I had to restart the server. Yep, so I forgot to, I made a change to the server, but I didn't shut it off and start it again. But you'll see it's working now. Now I just want to take you back through again for a second. Think about how we went through that problem together, because about, I don't know, 2/3 of what went wrong I had a good idea of what it was, and sometimes I didn't. So we saw that on VLab, when we tried to run our full test, the big one here, it didn't work. We weren't sure whether it was our code or the library, so we shrinked our code down to very little, and we ran it again and it still didn't work. So that tells us we probably haven't written bad code. It probably doesn't have anything to do with HTTP at all, because this has nothing to do with that. Then what we did was we said, let's try it on another machine. It's usually a good thing. Many of you have laptops, many of you have VLab. Sometimes you can try it, or try it on your team member's machine. We saw that it suddenly worked on another machine. That's good. Now we know it's related to the machine. Then, locally here, when I tried to run my test, I got that JSON error and the body wasn't being passed in. That was where I got tripped up. And again, the question is, what's different? What's different about my machine to VLab? Because this request file here, this nano source 5, this file, this was working on VLab, but it doesn't work locally. And again, if you would have stopped and said, what's different, we would have remembered that we actually went and updated our CRUD file here to have a few changes, such as, most importantly, this line of code here. And when we added that line of code, it all worked totally fine. So now that we've demonstrated that we can run our little tiny little program, let's actually run the jest tests that we were trying to run before. And then Jest should be pretty happy this time. There you go. So now we've got 2 ticks on Jest, because Jest has run those 2 tests here, and it has ticked them off. So you can see that using, a lot of what you'd be doing in iteration 2 with HTTP is really similar. It's just that instead of calling a function simply, you are dealing with this HTTP layer. Which does mean in some ways you might have to update some of your code, but that's also okay, because, this looks kind of big and scary, but think about it for a second. And this is a massive hint, but you could go and simplify this a bunch just by creating a function, and I'll just call the function like get, let's call it get. It's a terrible name. And all that takes in is, say, a path and a query string, right? So this is a function I'm writing now. And I'm just going to go and take all of this here and put it here. And what do we know about this that is common, right? Well, okay, const res equals request get the URL here, but then instead of Apple, we want it to be the path. But to do those strings, you need the funny little backticks. And then the query string here is just going to be whatever's passed in, and then we know we have to decode the body, and then we'll just return the body object like this. So now I've got this nice little helper function. So in my test here, instead of having to write all this, I could actually just say, well, const, what is it? Like const, const query, it's a terrible name, equals get, which is the function I defined up here. And I just pass in Apple, because it's, slash something, slash Apple. And then I just pass in the query string, which is this. And I don't need this bottom thing here, and then suddenly my code is simplified dramatically. And suddenly it's like it's not actually that much different to what you're doing now. It's just maybe the syntax is slightly different. And in fact, just to really kind of draw it out, what happens if I want a post one? Well, we know that a post one is very similar, except a post one takes in a path and a body. So if we come and copy like this example down here, we can now go and abstract that out if we want to. Pretty simply, where, similar thing, we have the path here. And then the body is just what's passed in. And we keep the headers there, and, we return the body object like this. And then similarly, instead of having to write all of this, we can just write, post orange, and then pass in Similarly, the object, like this. I could break it up into different lines if we want, like this. I don't think I need both brackets. Do I need both brackets? I think it's just that. Yeah, so, you know, and this is really great, because if you've defined that once, then you can reuse that, for instance, if you'd really like to, which is great. And if you want to take this really far, just to really drill home the example from the Advanced Functions lecture, what did we learn in the Advanced Functions lecture? We talked about this whole higher order component thing. Well, let's actually use that right here, and instead of get and post, because you see how there's some repetition here? Like there's the JSON.parse and the string and the request and the URL and stuff. Let's actually make another function that might be called, say, like HTTP send, and it takes in, say, a path and potentially a query string and potentially a body, or something like this. Maybe that's not the best example. This could go a little bit haywire, but I don't know. This would be fun. I'm just like thinking about the time. Let me just have a look at what we got here. We don't have a ton left, so let me just talk about this for like a minute. Which is that the problem is that these two are fairly separate. So what I could do here, for instance, try it out, is that I'm going to create a function that takes, and this is getting a bit complicated, is I have a function that takes in a path and an extra arguments. And what I'm going to have it do, like, let's have a look. What's the commonality between these two functions? You notice that they're pretty much the same except for the method, post, and for whatever this little thing in the object is here. You see how that's different? So what we might do here is we might go and grab this, just like we did before. We'll have a look at what's common, which is a lot of it. We'll replace this little object here with extra args, for instance. I will replace I'll put a method argument here, so instead of saying get, it's just method, right? And then path is already passed in, extra args is passed in, all of that's kind of the same, except this doesn't make sense already because we want it to be a higher order component, and what do you know about higher order components? You know that they are functions returning functions. So how this actually works is that I create an inner function, which might be like, I'll call it my inner function. And what this one actually does is this one is what does the work. So this will start to look very similar to the higher order components we saw before. And I've kind of put these in the wrong place because where this actually goes is kinda here. Where, and this gets a little bit annoying. This is why I didn't want to go down this example, because I think it's a little bit tricky. So like if you're kind of zoning out, you can just skip like the next 3 minutes. But it's like I have a function called HTTP send, which takes in a method, and then the inner function here is something that's created to be called later. So again, it's a function creating a function. And what I would do up the top here is I could actually remove a lot of this code if I wanted to, and just say that get is actually just the result of HTTP send get, and post is the result of HTTP send post. Now the reason this example breaks down a tiny bit is because these get and posts aren't perfectly similar to each other, in the sense that the extra args here is quite different. So see how here I call get and I pass in the path, which makes sense, but the extra args I pass in previously was like just the object. Whereas here, to get this working, I need to pass in the whole, you know, query string, blah, 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 blah kind of thing, which gets a little bit complicated. So there's some problems here, because what you'd realistically need to do is you'd realistically need to do a thing where you would have some kind of conditional here, such as, you know, you'd say that you create some extra object, and you say, you know what, if the method is post, or the method is put, right, then your extra would be like what we had previously, which was that your body is your extra args and your headers include a content type application/JSON. And again, that stuff you just copy and paste. However, if someone passes in, if the method is actually get, or the method is delete, then what you actually want is that those extra args aren't body and all that, they're just the query string. So that's why this example kind of breaks down a bit. It's not my favorite, but what we've kind of created here is one big factory function where if we wanted to now create generalized, functions for get, put, post, and delete, we can kind of do it here with limited repetition. So HTTP send is a function that generates other functions, and we've got it here generating an inner function. And so when we call HTTP send with get, it creates an inner function. And now every time I call get, it's like calling inner function. And quite literally, that's what's happening. When I call get, it's like calling inner function, except everything with method here is replaced with get, like that. And when I call it with post, everything with method here is replaced with post. So it's kind of like creating copies of functions in a way. I'm creating a get copy of the function, a post copy of the function. But again, typically I don't think this kind of thing would be worth it. Because the amount of repeated code is quite minimal. It's that's kind of clearer to read, right? And this is where you got to be really tricky. And we talk about this a bit next week, I think, where you got to be careful making things seem so tricky just to cut down on a little bit of repetition that suddenly everyone is confused and no one knows what's going on. So anyway, that was a little bit of a tangent, bit of a fun tangent. But that's jest. That's jest. We're tying it all together now, getting you ready for iteration 2. As I mentioned a few times, iteration 2 requires that you implement an HTTP server. However, many of the routes that exist in iteration 2 are just wrappers of the routes for iteration 1. And that's a good point, because as you'll see on Monday the 26th, 7th, I don't know, 7th, Monday the 27th, you will have a bunch of routes you have to do, or you have to write for this project, but there'll be things like, say, I'll give you an example. There'll be things like auth register. And this is really, really, really important. So have a listen to this. It's like, with auth register, it's not that you necessarily have to go and implement all of this because you're like, oh my god, didn't we already do that? And the answer is yes, because think about it. Auth login might be better. What does auth login, what does it do? Right? It takes in a username and a password. So we write that down, username equals request.body.username, or email, I think, email. Takes in an email and a password. So we do an email and a password. We grab those from the body. And then what we would probably do is we would say, I want to call auth login v1, and you just pass in email and password like this. And then the result you have here, what does auth login return? Well, it returns an auth user ID. So, for instance, and I'm not saying it does, but read the docs, but, this is kind of how you would wrap what you've done in iteration 1 around an HTTP server. So the point is that we're not trying to kind of scare you and be like, oh my god, you have to do all this stuff again. It's actually just, you've written a lot of basic functionality, and for a lot of that basic functionality, you can just wrap that kind of input-output around it, so that what you're doing with the server level is just creating a URL that when someone calls that URL, you just extract it, pass it to the function you wrote in iteration 1, and then you return what that function gives. So it's actually very manageable, and it's treating your iteration 1 functions like black boxes, and your tutors are very, very happy to help with this. Now, just some last really useful tips that I've slipped into this lecture. The first one is a really helpful and powerful library called Nodemon. And I'm just realizing, let me just check if there's a... I just realized that when we originally did this slide, maybe it works with Typescript. I think when I originally did this, we weren't going to do the server with Typescript. But let me just show you. So how this works is there's a library out there called Nodemon, which means, I believe it means node monitoring. And what that means is that we've seen before how we're kind of running a server here. But if I go and install this, and it's a dev dependency because it's only for developers, the way Nodemon works is that when I run some code now, particularly code that runs forever like an Express server, it listens to the file system on the computer, and if it sees that you save any file that it's using to run, it actually restarts the process. Now, I don't think that this will work out of the box, because I have to check something really quick. Sorry, I paused the recording for like a minute there, but basically I was worried about something that wasn't true. I forgot how powerful this library was. So essentially, I've installed Nodemon, and what I'm going to do now is that in my package.json, I've already got this ts node line here, but I can actually add this Nodemon line. And now instead of using ts node, particularly when I run the server, I can just use Nodemon like this. Nodemon is smart enough to figure out whether your code is JavaScript or TypeScript, and it's happy to run either. But what's interesting about Nodemon and why it's kind of exciting is that you'll see here that it's listening to my server now, which is good. But have a look what happens when I go to my text files. Like, let me open up the Crud thing here. And when I save the file, or let me undo it till the last changes, just so I don't break something. Yeah, so you'll see here that currently the server's running, and it's, saying thanks for sending orange. And if I open up the REST client and I call the orange API, I get 200 OK. But let's say I want to change that from thanks to thanks a lot for sending orange. So when I type in thanks a lot, when I hit save, watch what happens in the terminal. Nodemon was listening to the file system, all my files, kind of stalking them, and then it restarted the server. So now without having to stop and start it, if I run it again, the text is updated. That's a very, very, very helpful development tool. So that's helpful tool number one. Helpful tool number two is to do with Typescript, which many of you probably aren't going to look at a bunch, but but for instance, when you're developing something, and we'll probably talk more about this with some downtime next week, but basically what you should do a lot in you can try this out in your lab and stuff, is that if you just run npm run tsc, what will happen is that Typescript will run quite a strict check on all of your files for your lab or your project, and it will find errors potentially. Not sure if this will. I've changed a bunch of code, so this is testing all the lecture code basically, which is why it's like crazy. But it's finding all kinds of code, particularly with the stuff we modified last week. You see how a lot of 4.1 and 3.3 is suddenly breaking because we worked on it last week and made a bunch of problems with it. But what I wanted to show was that instead of kind of running this and then fixing your code and running it again, what you can actually do is just, run it. Oh, sorry, instead of just running it, you can actually add a -- watch command to it. So similarly, inside the package.json here, with the tsc command, you can add another flag, which is -- watch. And when you add -- watch, what happens is that tsc runs in a very similar way to Nodemon, in that it will compile your code, it will try and type check your code, and it will find problems. But let's say I'm going through my own code and trying to fix them up. For instance, let's look at an error here that we made the other week. There's a few of these that it doesn't really matter. The point is that let's say I go through my old file, such as like 4.1 map whatever, and then I go and make a change, like say I put 2 console logs there, you'll see that tsc will be listening to the file system, and it will similarly redo it. So these are two like really helpful things, because it means that you don't have to constantly like rerun terminals all the time. You can just kind of have these two things up. You might be asking a question again, which is, why do we need two separate things? Why don't we just have a process where if there are type errors, the server crashes, the server doesn't run? And the answer is, you could do that. We could set that up for you pretty easily, but it's not great development style, because having type errors in your code is common. It's like having poorly styled code. It's just kind of part of the development process. And whether it's every minute or 10 minutes or hour or day, you'll kind of come back through and clean up your code. So typically what you'll probably find is that you won't actually look at your Typescript checking as much. you'll be kind of just developing your work, and then maybe like before your merge request comes in, you might run TSC, see a whole bunch of errors, and then go back through your code and essentially go and fix them up. And that's where that watch thing is really, really helpful. The last thing is this actually slide should be deleted. Again, new course, tons of new content, and I was changing lots of things around. So you can ignore this slide. It will be probably gone from the deck by the time you watch this recording for most of you. So this was back when we were doing something another way, but I wanted to make it easier, so we don't have to worry about this anymore. So they're two really, really useful tips. That's all that we have for tonight. So please leave some feedback. It does, even if you're watching this with the pre-recording, you can still follow this link. It's totally easy. You just follow the link and then bam, you get the form. Really appreciate it. I guess just the last couple of points for those. I know many of you are not going to watch this lecture until after iteration 1's due. So like, I don't want to tell you anything like, good luck with iteration 1 being due, because most of you won't really watch it probably. But all I'd say is that the work we're seeing groups do at the moment is really great. It's really exciting seeing how engaged people are. Your tutors have been sensational. They're really wonderful people. If you're having a difficult group, please talk to your tutor. You'd be amazed how much work goes on behind the scenes, how much they care about you and your well-being, and how much we talk and make sure everything's okay. So, just keep at it and trust that we'll look after you, and talk to us all the time if you're feeling stressed or worried about anything. And I think that's it. Just good luck with it. And, it might be a little bit challenging, but we hope you're learning a lot. And that's kind of the main point of the course, is that you kind of come out of it being as good as you can be. So that's it from me. Please fill in the feedback if you can. See you all next week, week 5. Oh, I just remembered that Monday of week 7, I'm hoping to run an in-person lecture on campus. It'd still be online too, but if you're around campus on Monday of week 7 at the normal time, we're going to try and do something in person. So keep that in your mind. But I'll send info about that in the notice. So anyway, that's literally it from me. Thank you, everyone.